Today we discuss about the vectors. First we see the gradient. Now the gradient of a scalar rewrite as 1 by h1 del f del u cap plus 1 by h2 del f del v cap plus 1 by h3 del f del w cap. Next we see divergence. Now divergence of a vector field written as 1 by h1 h2 h3 into del u fu h2 h3 plus del v h1 fv h3 plus del w h1 h2 fw. Next, curl of a vector written as 1 by h1 h2 h3 into h1 u cap h2 v cap h3 w cap del u del v del w h1 fu h2 fv h3 fw. So these are the general form of gradient, divergence and curl. Now for Cartesian system h1 equal to h2 equal to h3 equal to 1. For spherical polar h1 equal to 1 h2 equal to r h3 equal to r sin theta. For cylindrical coordinate system h1 equal to 1 h2 equal to r h3 equal to 1. So this is the basic formula of gradient, divergence and curl. Now we see the properties of the vectors. First one, A dot V cross C. Dot V cross C equal to V of A dot C minus C of A dot V. Number 2, curl of product of scalar into vector will be equal to scalar into curl of A minus A curl of gradient of f. Next, grad dot A cross B equal to V of V dot curl of A minus a dot call of v normal vector for scalar component, then it will be n curve equal to grad phi by mod of grad phi. Next, if we write gradient of r to the power n equal to n into r to the power n minus 2 into r vector. Number 6, gradient number 6, divergence of r cap by r square equal to 4 pi del cube, 4 pi del cube. Next, 7, volume of parallel pipe equal to a b c, a dot b cross c, or equal to b dot c cross a equal to c dot b cross c dot a cross b. Now the area of the triangle, area of triangle equal to half a cross b. If grad cross a equal to 0, it is called conservative. It is called conservative field or irrotational field. Then we write the A is the gradient of some scalar. Next, if grad dot A equal to 0, then it is called solenoidal field. Solenoidal field. One important form. So the curl of divergence of a vector is always 0 and the divergence of curl of a vector is always 0. Now we see the linear dependence or linearly condition of linear dependence and independence. If three vector A, B, C, their determinant will be 0. If the determinant of A, B, C three vector equal to 0, then it is called linearly dependent. If determinant of A, B, C vector not equal to 0, it is called linearly independent. Next we see the equation on the tangent plane. Equation of tangent. Now for the equation of tangent plane, we first find the normal vector to this tangent plane, then find a vector which is going through this plane, and we see this normal vector and the vector AB which is passing through this plane perpendicular to each other. And if we take n cap dot AB is always equal to 0, and from this equation we get the equation of the tangent plane. For the equation of normal plane, we take n cap cross AB cap, n cross AB equal to 0. From this we get the equation of normal plane.